My name is Kenji Bramald. I'm a fourth year mechatronics student and I've been the team leader of team rUNSWift for 2 years. My team consists of computer science students and mechatronics students from the University of New South Wales, PhD undergraduates and alumni. So the SPL League is one league of the RoboCup competition. It's a league where each team has to use the same robot to play a game of soccer, a 5 versus 5 autonomous game of soccer where no one controls the robots. Once the whistle blows, robots run off, we just cheer on the side. And, the research that goes in is quite heavy. We spend maybe 20 to 30 hours every week per person on this, as well as our full-time study. What we do is pretty much everything, but apart from the operating system, is written by us, which means getting the camera image, processing that image to detect the ball lines on the field, other robots, and then generating how we move the motors to walk. And then finally, we have to make the robots communicate through the Wi-Fi network on the field. Actually, there was a big challenge this morning. We played on an indoor field just then, but this morning we played on an outdoor field. It was 9 o'clock in the morning, and there's a really strong shadows coming in. So that's what we were expecting. But this morning there was a huge fog in Sydney, which made the lighting very, very dark, which made the robots' cameras really hard to detect the ball. So that sort of dynamic change in lighting is quite a big challenge. And every year the league makes the rules harder to challenge us. So every year the teams get better. 30 seconds. Teams that are good have to release their code to other teams, so it's open source, which means another team can take their whole code base and run it next year. So the team that wrote it originally has to write something better next year to beat that other team.
The referee putting down and the ball is now.
The most challenging thing is to develop behaviours between different teams. Some teams have behaviours where they only dribble, but they're really quick at it. Some teams have really long kicks. Some teams have a bit of dirty tactics of kicking the ball out over and over. It's all part of the game. There's very specific rules. There's a whole 50-page rule book on this league. So trying to deal with all those things going on, and everything has to go well for a robot to kick a ball. So that's the difficult part, trying to make everything work perfectly. Without the open source, I think this league would actually not go forwards at all. Our team has had the fastest walk in 2014-15, arguably still have, and a lot of teams took our walk, and I would say more than half of the league use our walk now. But not all robots are the same, and robots overheat, batteries run out, and they start falling over more. So you got to consider all of those when you're developing these motions. Also, if you walk too fast, by the end they start falling over. So you got to conserve your energy during the game, just like a normal soccer player. So competition started off a bit slow. We're having issues with detecting the ball, and one night we completely rewrote our ball detector. And next day we played a completely good game. We were playing like 7-8-0 games between other teams. Semi-finals, unfortunately we lost, but in third finals we got back again. The final result was 11-2 to us, which is 1 point away from the mercy rule, which is where if you have more than a 10-point difference, the game automatically finishes. So that places us third overall, so we get a trophy. Well, I've been putting off my job search until this competition's over, but I think I see myself working in a robotics company. I personally want to work in some sort of animal or human movement. A good example is Boston Dynamics. They have really impressive movements. That sort of stuff I want to go into. Research or commercial products, don't really care.